This video is for problem 59 and for problem 60. Both of those are homework problems. As I said in the previous video, 59 is similar to 60 because if you look at the diagram here, it's the same as the diagram you have here, but problem 60 is asking you to find the current. Problem 59 is asking you to find the potential difference, but as we saw again in the previous video, if you have the current, you can just multiply by the appropriate resistance in order to find the change in potential. So this is also similar to the problems that we looked at just in the previous video for 57 and for 58, except that the diagram is different. So resistor 1 is now on this side. So that's the only difference there. Okay, so you need to find for homework the potential difference across R1 and the potential difference across R2 immediately after the switch is first closed. Well, when the switch is first closed, no current flows through this inductor, which means the change in potential across resistor 1 is equal to 0 because no current is flowing through this branch. And then if you go around the loop here, the sum of the potentials must add up to 0, so the potential across R2 must be equal to the potential across the battery. So you're going to tell me what that is for homework. Then for part B, you want to find the potential difference across R1 and the potential difference across R2 long after the switch is closed. Long after the switch is closed, as we saw in the previous example problem, delta VL is equal to 0, which means you can draw the diagram like this. Then you can use the loop rule. You could even color coordinate things here to find the potential across resistor 1 and resistor 2. Okay, so you're going to find that for homework. And then you want to know what the potential difference across R1 and the potential difference across R2 is immediately after the switch is open after being closed a long time. If you find, okay, so for problem 60, you're going to find the current through R1 long after the switch is closed. The current that's going through R1 long after the switch is closed is the same as the current going through the inductor in part C of problem 59. So when you find the current here, that's the current that's going through the inductor immediately after the switch is open, after being closed a long time, because the inductor is going to oppose a change in flux. So the current is going to be the same immediately afterwards. Once you find that current, if the switch is open, no current's flowing through here, so you can draw a diagram for that. There we go. Okay, you have the current that's flowing through here. I'm just going to call that IL, and that current would be going this way and then that way. You're looking for the potential difference here, which you would take the current, multiply it by R2 for this potential difference. For this potential difference, delta V R1, that would be your current times R1. Okay, so do that for homework. But the current that you have there, that's actually what you would be looking for in problem 60, part C. So when you find the current here, that should be the same as what you have for part C. Okay, so those are hints for problem 59 and 60, and that concludes the circuits section.